Bill Wheaton received a BA in economics in 1968 from Princeton University and a PhD from the University of Pennsylvania in 1972. He then joined the economics department at MIT and has been there ever since. Over the years, he has assisted many governments as well as the private sector, consulting with the Federal Reserve Bank, the Department of Housing and Urban Development, the World Bank, and the United Nations. Since this article appeared more than 30 years ago, Wheaton has shifted most of his work to detailed studies of the U.S. real estate market, which is much more profitable for him, but not really related to the issue of city size distributions. Hisanobu Shushido came from Japan to study economics with Wheaton at MIT, and they published this article together in 1981. The next year, Shushido went to the International Institute for Applied Systems Analysis near Vienna, where he wrote several reports and articles about urbanization and the distribution of cities, most often with a focus on Japan. He then went to work as a staff researcher for the International Monetary Fund, producing reports on economic development in Nepal, Vietnam, and other countries in Indochina. This article is widely cited even 30 years later because Wheaton and Shushido produced some of the clearest evidence that the size distribution of cities in a country tends to change as economic development goes forward, and that the optimum distribution of city sizes is different at different levels of development. Their findings have been confirmed many times since they first appeared here. In studies of the urbanization process, some scholars go beyond a single summary measure for a country, such as the percentage of people living in cities above a certain size. While ancient pre-industrial cities resembled the nucleus of a social cell that extended over the surrounding countryside and supported the urban residents, the increasing scale of production, transportation, and just about everything else in fully urban societies usually means that there is more than one city within any given society. Multiple cities in a single society raises another entirely new issue for urban scholars. Patterns that emerge within such a system of cities. Harrison examined one such pattern when they discussed central place theory, suggesting that a hierarchy of cities tends to develop, with many villages, towns, and smaller cities surrounding only a few really large metropolitan centers. Shushido looked into this question of networks or systems of city in more systematic detail. Jeffrey Williamson and other scholars already had investigated this question before them, specifically looking at what concentration measures. This article considers three of these measures of concentration. They start with the simple Primacy Index, which just divides the population of the largest city by the population of all cities added together. Using this index to describe overall concentration requires an assumption that the largest city and all the other cities are ranked in a relatively fixed, predictable hierarchy of sizes. A better measure, in their opinion, includes actual information on all these other cities, rather than just an assumption. They introduce the rank size rule, which says that the size of any city should be the inverse of its rank among cities, taking the size of the largest city as 1.0. If this rank size rule fits a set of cities perfectly, we can rewrite Wheaton and Shushido's equation 3 on page 19 slightly, so that the population, Pi, of any city is equal to the population of the largest city, P1, divided by the rank I of the city in question. The second largest city should be half the size of the largest. The third largest should be 1/3 this size, the fourth largest 1/4 this size, and so on. If this sounds fantastic and arbitrary, it may help to remember that we can derive some such expected distribution from cities that follow the central place theory. Approximation of this rule by adding together the populations of the second, third, and sixth largest cities in a society and comparing this sum to the size of the largest city. After all, 1/2 plus 1/3 plus 1/6 should equal 1. And believe it or not, when we plug in populations for Philadelphia, St. Louis, and Boston as cities 2, 3, and 6 in 1870, and divide the population of New York as city number 1 in that year by this total, we get 1.197, not too far above 1.0. New York City in that year was about 20% bigger than it should have been, according to this so-called three-city rule, a compromise between the Primacy Index using only one city and the full rank size calculation. Of course, a precise 1.0 score is unlikely to occur, but if we add an exponent alpha to the rank I in the denominator of the rank size formula, we can calculate the value of this alpha for any set of cities by simple regression. If it turns out to be exactly 1.0, it disappears from the formula, and we have a perfect example of the rank size rule. If larger than 1, the largest city is too big. The distribution of cities is top-heavy. If L is smaller than 1, the largest city is too close to other cities for this rule, and no one city dominates the urban scene. Of this alpha for countries around the world illustrate that those with an older urban tradition tend to have low scores, indicating several large cities, while cases of urbanization sometimes have scores well above 1 and are dominated by a single large city. But Wheaton and Shushido don't actually use either of these measures in their research. Instead, they use a different measure called H, basically because H is easier for them to calculate than the alpha parameter from the rank size rule. The alpha values from regressions probably would have different margins of error for different countries. But in this H measure, it had not been used much in studies of city size distribution, but it already had been used in studies of concentration of industries or minority groups. H value, we divide each city's population by the total urban population, square each result, and then sum all the squared terms for all the cities in a country. Remember that this H measure ignores any rural population, just like the other considered measures, and only divides by the total urban population. To make it done uniformly across countries, Wheaton and Shushido drop any towns or cities that are too small to appear in a list of larger places that add up to 70% of each country's total population. If there is only one city, this H calculation means 1 over 1, which is 1. Squared is still 1, which adds up to 1. 1.0 means total concentration in one city. If there are two cities of equal size, this means 1 divided by 2 is 1/2, squared is 1/4, adding both fourths together is 1/2. Cities, and they're all the same size, this means 1 over 10, or 1/10, squared is 1/100th, added up 10 times is 1/10. If all cities are the same size, the more cities we have, the less concentration there is, and this makes sense. If we could find 10 cities that followed the rank size rule, this H value for them would turn out to have a value of about 0.18, or about twice as big as the all cities equal result, but nowhere near total concentration. Decimal numbers might be a little hard to interpret, though, so Wheaton and Shushido invert these results. 1/10 becomes 10, 1/4 becomes 4, but 1.0 remains 1.0. On their page 21, they point out that in this inverted form, the value of 1 over H can be thought of as the number of equal-sized cities needed to include 70% of the total population. More cities needed means people are less concentrated in any one city. The urban population of different countries may concentrate in the biggest cities, or on the other hand, disperse out over many urban places. The scholars who constructed measures like the Primacy Index, the rank size rule, or the H index were motivated by the idea that there may be too much of a good thing when it comes to such concentration. Wheaton and Shushido are working from this starting point when they go looking for patterns in values of 1 over H, which measures how many cities it takes to capture 70% of a country's population. After all, the rank size rule implies that there's an ideal pattern of concentration that results in the exponential series of city sizes. More concentration than this is primacy, and that's bad. Not enough concentration doesn't get blamed for various social and economic problems, but it also isn't seen as optimal. But what makes some particular degree of concentration among cities better than some other lower or higher level? Wheaton and Shushido draw on economic theories in order to suggest some forces that affect this degree of concentration. First of all, they suggest some economic reasons why people and jobs and money might concentrate in just one or maybe just a few cities in a country. They know that probably the most powerful factor in increasing productivity, wealth, and the level of living in any economy is investment of capital, which makes the work that people do more efficient, productive, and profitable. This in turn generates more capital, and if that also gets invested, we can find ourselves in a self-reinforcing upward spiral. This spiral is none other than the elusive economic development that everybody talks so much about. But if a society has a very low level of available capital and productivity, the scarcity of that little amount of available capital means that it may be best to invest most of it in one place, as opposed to scattering it out all over the landscape. Another advantage of concentrating investments in new productive enterprises is that you can make one big factory instead of 100 little workshops, and the factory will experience the well-known advantage of economies of scale. For example, if a cobbler sews one pair of shoes by hand per day, the price of those few pairs of shoes will have to be high enough to support the cobbler and his family. If somebody builds a shoe factory and produces 1,000 pairs of shoes every day, the price of all those shoes can be much lower and still pay for the factory and the wages of the workers and leave enough extra for a nice return on the investment. Once some producers and other businesses get started in such a chosen location, it also makes sense for other businesses to locate near them, because those other businesses provide them with raw materials, component parts, and services like accounting, legal advice, or advertising. So Wheaton and Shushido consider that in such a situation, a high level of concentration of people, money, and jobs in a central location may be the most efficient approach and produce the best economic outcome in terms of faster growth. They call all these advantages of concentration production efficiencies. On the other hand, though, if all the people and jobs and money pile up in just one big city, what happens to the rest of the country? Thousands of pairs of shoes are no good piled up in a warehouse in the center of the city if the customers who need them are scattered over the landscape far away. To the extent that there's a large, widespread market for goods and services spread throughout a country, producers also need to find efficient ways to transport all of their products and to deliver their more intangible services to these consumers. This might even suggest that the 100 little workshops might actually be more efficient in the end, even if they have inferior production efficiencies, because they have superior efficiency in delivering the goods to the consumers. So the central point of the whole article by Wheaton and Shushido is that in every society, any firm that wants to be efficient and stay in business has to perform a balancing act, finding the correct trade-off between the production efficiencies that come from putting all your eggs in one basket or city, and the transport efficiencies that come from putting your business where the customers are, or at least where you can get to them efficiently. And of course, if the businesses locate in the most efficient balancing point in order to succeed, then the people who work in those businesses also must go and live in those same places. The result is some observed level of population concentration distributed across the cities found in that society. When Wheaton and Shushido put the issue in these terms of a balance, then it clearly becomes possible to decide whether a country has found the right balance of concentration. The faster the economic growth in the country, the more efficiently the capital must be invested in order to generate the upward spiral of development. But in addition to this valuable idea of the trade-off of efficiencies and the optimal balancing point of concentration, they also point out that there is another conclusion built into this same picture. In any balancing of conflicting goals like this, the exact point of the balance depends on how important each of the goals are. If I am both hungry and sleepy, I have to choose a trade-off in terms of which thing to do next. If it's early morning and I just woke up, the hungry side of the balance is more urgent and the sleeping part not so much. If I just got home from the restaurant after an exhausting day of running all over the city on business, the sleeping side of the balance takes priority. In the same way, Wheaton and Shushido tell us, the effective demand for products and services in the country as a whole may be limited because the population in general is mostly illiterate and engaged in subsistence agriculture with no money to spend on anything. Then the advantages of productive efficiencies from concentrating capital in a central place are likely to take priority and to lead to higher concentration of the urban population in that place. On top of that, the production that does take place in that primate city may not have to be distributed. It may go straight into ships and airplanes and be exported out of the country by multinational corporations. So in some situations, dominated by considerations of productive efficiencies, a high degree of urban concentration may be the best outcome in terms of development and capital accumulation. We also acknowledge that the mirror image of the primate city situation may be an optimal outcome in its own time and place. When a country has a widely dispersed population with effective demand for products and services, and when there is a well-established supply of capital to invest in production and other firms, then the considerations of transport efficiency may be most important. This will tend to spread out jobs, money, and population over the whole network of cities in a country in order to get the products and services closer to the customers. In other words, the optimal level of urban concentration is not some kind of magical, timeless constant, as implied by the rank size rule. This optimum distribution of urban population across cities depends on the situation in the country and relative importance of the goals of production efficiency and transport efficiency. Rather than asking what is the one best value for a concentration index, like the value of 1 over h that they have calculated, Wheaton and Shushido ask a more complicated question. How does the best level of urban concentration change over the course of the transformation from a pre-industrial to an industrial society? Once Wheaton and Shushido have decided on their 1 over h measure of urban concentration, and then developed their economic theory of what might determine the variations in concentration that we find in different times and places, they are ready to test their ideas by checking them against the facts and figures from various countries around the world. They construct a mathematical model of how concentration ought to be related to the economic growth and development, shown as an equation in the article. The 1 over h outcome is on the left side of this equation, and the level of development measured as gross national product per capita is on the right side. It appears on the right side of the equation twice. A lot of assumptions with this model, such as the assumption that a higher level of GNP observed in a country means that accumulated capital has been used more efficiently there, producing a higher climb on the development spiral. Their discussion of the conditions that make production or transportation more important also carry a strong suggestion that in general, as a country gets more developed and its people achieve a higher standard of living with more education and money available to generate demands for goods and services, over the long haul, the transport efficiencies probably tend to get relatively more and more important, dictating that the value of the 1 over h measure should be increasing with development most of the time. Remember that this 1 over h measure represents the number of equal-sized cities that it would take to hold the urban population of the country. So higher values of the index mean the population is dispersed out across more cities. We're concerned that in some situations it may make sense for a country to become more concentrated in just one or a few cities rather than less. This is seen when they talk about a non-linear equation like this one shown here. In a linear equation, the assumption is that the path of urban concentration follows a straight line in one direction as development goes forward. In this case, it would be a straight line of decreasing concentration from one pre-industrial city to an urban society filled with many cities. In your equation or model, the path can curve. It can go up part of the time and down part of the time. This curvature is allowed by the extra time that GNP appears on the right side of the equation, and its extent is reflected in the beta 3 coefficient that goes along with that extra GNP term. To test their ideas, they take data from the National Accounts Yearbooks of the United Nations for 38 different countries around the world, where they can measure both the distribution of cities and the level of gross national product per capita. Use statistical analysis to find the line or curve that best fits the distribution of these 38 countries, with the 1 over h index measured on one axis and the GNP per capita measured on the other. And it turns out that a curve does fit the data much better than any straight line could, so they keep their nonlinear equation as the best choice. The best fitting curve for these 38 countries, shown here, means that at the lowest levels of development, measured by GNP, the 1/H index does tend to fall as GNP increases. Money and people are concentrating in fewer cities for the countries that appear further to the right along the development process, at least at first. There comes a point, just as they expected to find, where the advantages of productive efficiencies no longer dominate the picture. A level of about $2,000 per person of gross national product, a tipping point where countries begin to disperse their populations out over more different cities as they reach higher levels of development. The line on the graph bottoms out and begins to climb, indicating higher values of 1/H, or more dispersion of the urban population into more cities. So if they're correct in all their assumptions and analysis, there is indeed a predictable pattern of variation in how urban concentration tends to vary with economic development. We can imagine a hypothetical country following this path. At first, when capital is scarce and the population of the country as a whole has little effective demand for goods and services, the priority on productive efficiency concentrates the jobs, money, and people in one or a few cities. As development continues as a result of the growth achieved, eventually the population begins to be able to afford those goods and services, and the firms have to adjust by paying more attention to transport efficiencies. The jobs, money, and people begin to disperse out across the country into more cities. There is no one magic number like the rank size rule that fits all times and in places, according to Wheaton and Shushido.